So we have a surprise here today. You can see I have an array of different packages here, and you also notice an array of different multimeters set up here. That's right, we're going to look at some new multimeters that I got in. We're going to do some basic testing on it. Voltage, I have a voltage reference here that I built. It's a 10 volt and 5 volt voltage reference within a 0.0025% accuracy. It does pretty well. We're going to use this as our standard load test, and I'll actually confirm the load using my calibrated HP34401A, and I have some precision VGA resistors located in here, as well as some 1% resistors in here. I'll take this apart and show you how this is done. I really need to build a proper box with banana connectors on it, maybe do a 3D print one. Just haven't gotten around to it to do the time. And as far as measurement tests, we have multiple different probes over here. Your standard K-style, K-type probes and what have you. One came with a Fluke, one came with an X-Tech, and we're going to compare that to my flare. So we can use the flare to actually confirm the temperature readings of some of the devices that we'll be doing some testing on. As well as, let me see, I believe I have, here we go. I might have to wire one up, but I have a PTC heater here, which gives off about a 70 degrees Celsius accurate and pretty darn stable, actually. I'm really impressed with these old PTC heaters. I bought these for a different project, but we can use that as the regulated heat source without having to hook up a pit or anything else to regulate the current to a heat source or a heater element or anything like that. So let's go ahead and dive in, take a look, see what we got. First off, these are going to be some of the reviews I'll be coming up with, not right now, but I'm going to have this. This is a new company called B-Side, and this is their DC clamp meter. And I've already done some playing around with it. I've already done some measuring with the clamp, and I'm kind of impressed with the accuracy of the clamp actually so far. Even at a millivolt range, it provided more than I expected, honestly. Also, we have the AMO meter, and this is a multifunction process calibration meter, and I'll be doing a review on this as well here coming up soon, and we'll do some testing on this and see how this handles and all the different things that it comes with, the different probes and what it can provide as well. Now, a process multimeter is different from your standard multimeter. It's more specific to automate a process for testing certain equipment, and most of the case for your general hobbyist, it's not going to be something that you'll be buying for your bench, but there are people out there that I'm sure will be interested in this meter as well, so I'll do a quick review on that. Now, for the one I've been waiting for, and the special package here, let's see how well it was packaged. Here we have your standard invoice. And the invoice date actually says November 2nd of 2006. I think he had a problem with this. He's corrected that since then, though, so I'm sure the invoices after mine were correct. This was not ordered November 2nd. It wasn't even available November 2nd to my knowledge. But I'll get the proper date. I'll log into the site and tell you what date I did order it. All I know is for shipping from Australia, it's the first time I've ever ordered anything from Australia, and I was surprised on how fast I actually received it. When I went to my mailbox, I really didn't expect to see it out there already. And to my surprise, there it was. It is the Brymen 230 series meter. This is my first Brymen meter, so we can do some meter comparisons. Of course, when you do meter comparisons, there's people out there going to be like, what are you comparing this meter to those for? I mean, we don't know much about those. Well, we also have our trusty Fluke 289 here to compare it with, as well as our calibrated HP34401, which has the calibration date sticker of November 11th, 2015, and is good until 2016. So let's go ahead and open this up, because I think you might be surprised on what's actually inside. The box doesn't really give you a clue, but if you look inside here, we got our K-style thermostat. We have some nice probes in here with some input protectors on them. See here. And the color may have given it away. That's right. It is the rebranded BM235 Brymen EEVBlog in the special blue color with the Dave Jones input on. He does say minor input on some of the design and operation of it. Now, Dave's theory, if you've ever seen his channel, and if you haven't, I highly recommend it. Go ahead and click the link down below in the description. I'll put a link to his video channel, EEVBlog, and also the EEVBlog.com for his forum and his store. Highly recommend it if you're looking for any advice on purchasing any equipment. There's a lot of knowledgeable users on there. We also have inside here the manual. There we go. We'll set the box aside. Actually, let me go ahead and pull these probes out. And as I was mentioning, if you've ever seen Dave's channel, his normal theory, of course, is don't turn it on, take it apart. Now, I could follow that theory, but then I'd feel like I'm just copying somebody else's channel, and I usually don't do teardowns of meters, but since I've been getting a lot more multimeters for reviewing, I'm probably going to start doing just that, except I probably will start with Dave's, only because I know Dave's meter, in the manual, it actually says he encourages you to take it apart. So it does not void warranty. It has a very specific writing with the not being big and capitalized. Does not void warranty. He encourages you to take it apart. So of course we're going to have to, but instead of following Dave's format of tear it down, or don't turn it on, tear it down, I'd rather turn it on first and make sure it works, because shipping back to Australia, well, you know, it wouldn't be Dave's fault. It's a rebranded meter. It has his name, has a little input on it. He has some say-so in the probes that it comes with, but in the end, you know, manufacturing errors do happen, so I'm going to just do some basic testing on it first to make sure everything works and operates before I do a teardown on it. So you get your basic user manual, and this is for the BM231, 233, and 235 Brymen. And this is not the Dave modified manual, I don't believe. This is the standard manual that comes with the Brymen because it's suited for all three of these meters. On his website, in his store, under this product, you will find a PDF file. It is Dave's actual branded meter manual. And let me see if I can find some pages here. You'll see here, he has little text here in green, and the green text is his notations. It says Dave's note, and he has little parts that are put in red. So Dave's note, you can use the auto low V, low Z mode to discharge capacitors, stuff like that. So if you want to see Dave's comments and specific to Dave's meter or his rebranded meter, be sure to download Dave's manual off of his website. And so far, I can honestly say, from look and feel, let's go ahead and put that manual away, since you saw I already have the manual downloaded here, so we don't need that manual. Excuse me. As far as look and feel, I can say, being my first Brymen, I've had one other Brymen in my lab, and my best friend came out to visit from Philadelphia. He brought his Brymen with him. It was almost as big as my 289, but it was quite an impressive little meter until we had some problems with it, actually. We were trying to compare it to my Fluke 289, and it started messing up. Since that point, I'm sorry to say, my best friend has been dealing with it's a company called TME, Tom, Mary, Edward. And they finally refunded him after having his meter from an RMA for 4 months. They had his meter for 4 months out of the year. It only has a 1-year manufacturer warranty on it. They weren't able to fix it. They claim it was scratched when it went out to service and it came back to them, so they just gave him his money back. I was actually looking forward to receiving that meter because I wanted to show what the problem with that meter was, and I also wanted to do a teardown on it and see if we could figure out what was wrong with that meter and maybe do a repair video. But because they kept the meter and they gave him his money back, I won't be getting that meter. Part of my original plan is, and the reason I contacted Dave for this meter is I said, hey, I want to buy this meter because my buddy really loves the Brymen meter. He just happened to get one with a problem, and it happens. I don't care who you are, if you're Fluke, Apple, HP, Agilent, once in a while you're going to have something that rolls off the bench that's going to have a problem. You're not going to have a 100% manufacturing record of everything being perfect. And you have to understand that. You may be the unlucky one to receive one with a problem. Not your fault. It happens, but that's what warranties are for. Test it, send it back if you have a problem. The unfortunate part is the sending back is what my best friend ran into, and trying to get it repaired in the 4 months it took. So I was going to send him this meter. He was going to send me his broken meter when he got it back from TME, and I was going to tell him I was able to fix his meter, and I was going to send him this one in exchange and kind of surprise him with this meter. Unfortunately, the cat got out of the bag on that one, because he ended up going out and buying a Fluke 17 plus B, and also got refunded for his TME meter. So I kind of had to let him in on, you know, what the deal was, and I was called a sneaky bastard for even planning it. And well, now I own an EEVBlog BM235, so this is my first Brymen meter. Let's go ahead and take a look at it. Pull that cover off there so we can scratch up the display as we use it, of course. I say first impressions, I mean, size-wise, it really is a huge difference. I mean, we all know the 289 is a big meter, but even not even compared to just the 289, I mean, take it against your standard X-Tech size meter. Let's go ahead and pull this X-Tech out here. This is a Southwire. It's rebranded X-Tech, basically. Still, a little bit bigger than your standard X-Tech meter, but you gotta understand what you're getting in here is a lot more features, a lot better accuracy than this X-Tech meter, as well as a Cat 4 rated protection. This does not have a Cat 4 rated protection. This only will do amperage. It does not do milliamps or microamps on the current readings, as the Brymen BM235 does. This has a voltage detection or high voltage detection. You can actually use the common jack as a antenna lead to actually detect voltage in your circuit when you're tracing down wires. It has a recording function, which gives you your mid-max and your highs and lows. It has manual ranging. It has a hold button. It has wow, it just there's so much to this meter, more than this has. You know, capacitance, resistance, of course, low Z, which I've only seen in some of the high-end Flukes, like my 289 has low Z, and I use that to discharge capacitance on some capacitors while working on high voltage items that may have broke over time, like a power supply. So for the size of this meter, to be able to do probably everything that my Fluke does, except for, you know, logging it remotely to a computer, I can see this being one of my go-to meters. I can see this being one of my main meters. It fits really nice in the hand. I have averagely large hands for being a 6'2" guy, but it does fit nicely in my hand. And you can see there was cutouts here for the data transfer, you know, for the IR receiver or transmitter back and forth for logging data. This model does not come with that, so that's why you also don't see the IR cable. Let's move these cables out of the way. These are here for when I go to plug in different amperage testing and what have you. I'll set these aside for the time being, so we don't get these cables all mixed up. Instead, we'll put these cables up here and the thermometer. It's got a nice little stand in the back. Not bad, actually. I'd say it does pretty well. I'm used to them being a little wider, so it has a little bit of a rock, but you have to hit it kind of hard to even, well, that one did it. It's got a good stand. I mean, it's not going to shake off your desk. If I hit my desk, I hit my bench, you even saw my Fluke jump there. I hit that pretty hard. It's going to stay standing, so I do like that fact. Dave's input on his special request for his probes, and I can tell you these are really, really nice. These are nice feeling silicone leads here. I like these. Compared to the Fluke leads, they hold a little bit more. You can see how it's kind of held that position from being wrapped, where the Flukes just kind of come undone and they don't really. Maybe these have more twines of wire in it that it's, you know, that it's holding that way. But they are nice leads. The texture is nice. It's got a nice feeling, real comfortable on it, especially above the protection rail here. It's got some good feeling to it. And let's go ahead and put the Flukes down. If I was to compare these to my Probe Masters, about the same size leads of the Probe Masters. And again, the Probe Masters have more of a Fluke silicone wire quality to them. But these are really good for the price, actually. These are a lot better than I expected. I mean, this meter, I think, came a little bit over $100 after shipping from Australia to the US for US currency. It ran about $100. And the nice little feature about this, of course, we have our caps, which to put these caps on, you have to unscrew the banana connector. Gold plated leads, banana connectors, and there's our Cat 4 protection caps on the probes. Really nice, sharp, pointy ends. I like that. Not owning one before, I wasn't sure how to get that off. I noticed there's a little round notch in there. Maybe it's to use the other probe, so that way you can get it started to get it off. I don't know. But if you just pull, it seems to come right off, so we'll just do that. We'll pull them off. Not like I'll be needing the Cat 4 protection that often, but in case I do. The nice thing is they work as banana jacks. They have these nice, in fact, let's get a somewhat closer look at this. You can see that you have these nice little banana jacks here, and they're screw-on threads. So they're not going to come loose easy. So you can use them as your standard probe, or you can use them as a banana jack and plug them into whatever test equipment you're running, if they come equipped with banana jacks. I really like that. That's nice. The only other sets of probes I have, and I have about anywhere from 10 to 12 probes probably in my lab. The only other probes I own that has any type of screw-on thread for accessories to attach to it so they don't come off easily is the Probe Masters, and these are fairly affordable probes as well, but they're not exactly your low-end probes. Some people aren't willing to spend $20–$30 on a pair of probes, and just to have that screw-on feature and that type of quality with a meter in this range of $100 is actually a nice little feature. I like it. Let's go ahead and set that aside. Let's go ahead and not too much to see here. This is your basic case style. It even has the letter K. It's got your positive and negative markings on it, so you know which way to plug it in. There is a little red dot that also indicates positive, and it's a very small red dot. The positive and negative are a little hard to see. Let's go ahead and pull it out. I will say that they are a little hard to see because the markings are the same color as the housing itself for the jack, but you can see it does have a little red dot there, so that's your indicator of which way you want to plug that in. So let's go ahead and turn the meter on, because I'm really curious about turning this thing on here. Actually, let's go ahead and pull the... Wow, that's a nice tight fit. I was expecting that to come off a lot easier. I like how tight that fit is on there. Good. There it is. And I was pulling this off just to show you what kind of batteries it took. So I'm not gonna, like I said, I'm not gonna do a full take it apart, but apparently I have to take it apart a little bit here to show you the kind of batteries that it's using. And the screw you can't lose on the battery backing. Yep, you're not going to lose that screw. It's staying there. That's good. And right away you see two AAA batteries, and it came with the batteries included. Really nice touch. And a couple of nice proper fuses. These are proper HRC fuses, which is definitely a good sign. And you can see, you know, I wonder if the meter would have been a little thinner straight up and wouldn't have had this arch curve if it wasn't for the battery layout and where the fuses had to be put. And some of the design choices between where the fuses had to be put has to do with the internals and the Cat 4 rating on such a small meter. And I don't mind that curvature though. Like I said, that curvature actually makes it feel nice in your hand. So we'll go ahead and put this back in. On the back here, you will see that we have some little slots here that come off the back that actually push against the batteries, so the batteries won't be knocked loose easily, which is also good. Now we'll turn it on and put the case back on it. And plug some probes in. Let's see what this thing does. I believe this also has probe detection, which is only seen in one of my meters right now, and that is the Fluke 289. So it's a nice feature for a $100 meter to have probe protection. Kind of really like that. Kind of excited about that. As we turn it on, it's got a fast startup. Boom, right to the voltage. There it is. Nice, clean looking display. Really nice, clean looking display. Happy with that. You got your hold button. You got your max, mid, and your average ranging. And it beeps every time. There's your max, there's your minimum, and there's your average. And then that will show you everything. And every time it picks up the new rating, it will beep to let you know that the rating has changed. If you hold it down, that will turn that off. Let me see here. So we have our auto range, which it automatically goes to, or you can choose your manual range. This is a 6,000 count meter. For this size and this price is very nice to have. 6,000 count meter. Again, hold down your range and it goes back to auto. Your select button automatically put me over to a VFD, DC, AC. I'm not sure what the VFD is. I'll have to look that up. The VFD is actually stands for variable frequency drives. This enables a digital low pass filter to actually filter out some of the noise when you're reading your voltage or your hertz in a noisy AC environment. So that's actually a low pass filter. Well, it's a digital low pass filter that's enabled on the VFD, which is a nice little feature too as well. And if you hold down your select button, there is your backlight, and that is a really nice, clean, well lit backlight. Except I hear a little whine. Now I don't know if that's a capacitor or if that's just the LED display, the LED that's driving the backlight display. Let me go ahead and bring the microphone in here. Mr. Microphone should have the sensitivity to pick this up. Let's see if we can hear it. Let's get that. Yeah, that is a little whine coming from there. Well, I don't know if that picks up on the mic or not. I hope it does. I'm not sure if that's just my meter. I only have one to compare it to. Of course, I don't have any others to actually, compare it to, or any other Brymen meter for that fact. So maybe it's a common thing for Brymen meters. I really can't say that, being my first Brymen meter, kind of did shock me. I mean, I heard it visibly with my ears, and there's another light on my bench right now that actually has a high-pitched whine. In fact, I use them as my studio lights. It's these multi-LED lights here, and these will throw off a little bit of a whine, but I expect that. That's just kind of part of the design of driving so many LEDs on that it's going to have that type of that kind of whine to it. But it's really high-pitched. You have to get really close to it. I'm a good 14-15 inches away. My ear is 15 inches away from this, and I turned that on and heard that. Which I think that was the surprising part, is the fact that I heard it so obviously and so fast. Oh no, still a really nice meter. I'm still enjoying the feel of this. I really can't get over the weight of it, the feel of it. This is the EF. This would be the high voltage detection. See if I have anything here that I can trigger this with. Now I also read that you can use the negative terminal to act as an antenna for your high voltage detection. As you move the meter closer to a live line, you get a stronger signal. More dashes come across the screen, and the pulse picks up. But you'll never get higher than 5 dashes and a very, very fast pulse. Or a very, very slow pulse if you're far enough away. That's the most you'll get. But when you're using the probe, if you're actually looking for a live line, you're not using the field detection. You're actually going for a direct single. This is why you don't need to use 2 probes to test to see which line is live. You don't need to have 2 hands in it. You can actually use a single hand. There it is. Boom. All 5 bars, constant tone. That's a live line. That picked up a little interference, but there it is, live line. Great. So you can see I got 124 volts, 0.373834, 124.33. I'm going to do a hold on this. So that's our AC line. Well, apparently my hold didn't work. Although, this guy's going crazy detecting the power going through my fluke probes. There we go. So that's my AC line in my house. Go back in here and we'll actually check our recorded rates for our min-max. And as it picks up and zeroes out, there it goes. So our minimum was 124.3, which matches the 124.31 on my fluke here. The minimum 0, and the average, of course, is a constant changing variable. But all in all, that's exactly dead on with the fluke. Can't complain with that. That is perfect. Great. Very good dead on. And of course we have our hold button and we can hold that. And if we hit hertz, we'll see this is at 59.97 hertz, which I'm in the US, so my mains is a 60 hertz. And I can actually do my min-max on that as well. That's a nice little feature. Turn on the backlight. And we'll do a hold on that. And we'll take the hold off of here. We'll go to range on my fluke. Oh no, we'll go to min-max on my fluke here. There we go. And we'll plug my fluke back in. And let that come up with 124.3638, flipping around there a little bit. So let's pull up my menu here and check. My hertz is 59.989982, and we'll hold it right there, 989, 59.97. Can't complain. Pretty much bang on with my fluke right now, which is very impressive, because none of my other meters come close to being bang on with my fluke or with my bench meter. So the fact that it's coming this close is really a nice job. We'll put the AC line away. Still hear that little whine. I was kind of hoping that would go away, but it didn't. No, I'll leave it off right now. It's kind of annoying. Alright, so we detected the hertz, no problem. See what else do we have here? Continuity. Really, really nice, fast, responsive continuity. I really like that. I only have one other meter that is that fast, honestly. Guess which one? Really like that. That was pretty quick. But for noisy environments, I've never seen this feature. That light up feature. That is really nice. So if you're in a noisy environment, you can still tell by the light that you've made a connection. What happens if the light's on? The light goes off. It blinks. So it blinks off, it comes back on. Goes into a on-off blinking mode. So even if you had the light on, you still had that visual confirmation. How nice is that? I love it. If I hold these, does it blink on and off? It does. A little slower because it's doing the opposite rate of if the light's on, so slightly different flashing rate, but still really nice. That was pretty cool. I like that. And then of course we have our resistors. So let's go ahead and see what we got here. Let me introduce you to, I'm going to go ahead and put my banana pros back on here before I lose those. I really like these little banana connectors. I don't want to lose them. Oops, upside down. They only screw on one way. But let me go ahead and introduce you to my $100 resistor box here, which I really do need to 3D print a much better box for this, but for right now, this will do the job. It's going to have to do the job. So what I have in here is I have multiple VJ resistors that, if you want to look up the part numbers, this is a 1 ohm 0.1% accuracy resistor here in the back. This is a 10 ohm 0.05% here, 1K, 10K, 100K, and these are all high precision. Model number RNC90Z VJ resistors, so you can look up the RNC90Z and actually look at the specifications on these. These are military grade resistors. And then I have a couple of 1%ers here for like I think it's a 10 mega and a 1 meg 1% resistors. Let's go ahead and go around, and usually I'll keep this in the box, but you know, just so you know which one I'm actually measuring. So that's our 1 ohm resistor, and that's held right down to 1 ohm. Look at that. Wow, that's very nice. I like it. In fact, you know what? It's going to be a lot easier to get these resistors without these banana connectors on, so let me take those off. Now, I didn't even reference that out. I didn't zero that out or anything. In fact, it doesn't need to be zeroed out with these probes. It auto-zeroed right down to where it belongs. So no need to reference it out, no need to null it out, zero it out, whatever you want to call it. Seems to be doing a really good job. Let's go ahead over to our 0.5% accurate 10 ohm resistor. Brings it right in. It's within spec. Now these are a lot higher. And that would be my 1K resistor. Comes in at 0.999. My 10K resistor comes in at 9.98K, which is still within spec, I believe. I'll have to look that up on the data sheet and confirm the tolerance is correct. And my 100,000K resistor, which is 99.8K. I still think that's within spec too. And then, like I said, I had a couple 1% tolerant resistors here. For the mega resistors, this is 1 ohm, or 1 meg, sorry. Which is actually bang on. There we go. And this should be a 10 meg, I believe. If I can get my probes to stay in one spot. And there she goes, right down to 10 meg. Perfect. Like it a lot. Now, Fluke does have a low range, so let me go ahead and turn this over to resistance. We'll go through the same thing here. And that comes in at 1.01. Fluke also has a low range tester for resistance. You might read that 1 ohm much better on the low range. $10 ohms bang on. 1K. So you can see how accurate these resistors here, especially these last three, the 1K, the 10K, and the 100K. I spent about $25 a piece on each one of these. 10.003, well within spec. And 100K, 100.01, 02. And for the 1%ers, 1 meg and the 10 meg. We'll use the 2-wire. It does have the 4-wire functionality, but of course I don't have my 4-wire Kelvin set up, and that wouldn't be fair to compare a 4-wire resistance reading to a meter that's only doing 2-wire resistance. But being as the fact that this is such a an old meter, Apparently there's no resistance on my probes. So I guess I don't have to reference anything out or null anything out here, huh? There's a little bit once I go over to 6-digit. We'll null that little bit out. And this is how you know how accurate these actual resistors are. There's my 1 ohm resistor. My 10 ohm resistor. My 1K. Whoops. $1.00009K, 10K, 10.0012K, well within spec, and 100K. Which is actually showing up as a 0.1 million, 0.1 mega. Both ways of reading it is acceptable. I could manually change the display to read as 100K instead of a 0.1, but it wouldn't make a difference. I mean, it's obviously still the same. Comes up as 1.000111 meg, and the 10 meg, 10.00165.194, 10.0024, still good for a 1% resistor. So yeah, so far the readings off of this guy are very impressive. Cannot complain about that at all. Definitely like it. One of these days I will print an actual box for this with banana jack connectors and everything, but for the time being, that will do. It's gonna have to do. I have no choice because, well, I've been lazy and haven't printed anything yet, so that's it. So now we got that pass done. Let's see, we got our millivolt and our temperature. I don't know how I want to set up this for checking the temperature. There we go. Unwrap this guy. So 73.6 versus 68.7, 68.8, and it's still not done warming up. I can tell by the amount of milliamps it's drawing right now that it's still climbing. It should go down to about 9. Oh, nope, it just reset. You can tell when it flips on and off there. Very responsive on the BM235 Brymen for it to see that on and off drop of current and change the temperature that fast. I like that. That was nice. I'm actually very impressed with the temperature reading on this Brymen right now. I'll remove the fluke probe, so we'll just be reading it with the Brymen, and I'm down to about 9 milliamps of current drawing on it, which says it should be at about full temperature. And here's where I'm having the problem, because I got that reflective surface, and I got to get my flare at the right angle to compare it. I'm picking up 69.4. Wow, that's dang on. That is amazing. I do like the temperature probe sensor on this Brymen. I've seen some good temperature sensor probes, but usually not on a sub $100 meter. And the problem with K thermometer thermostats is you got to have the positioning just right to actually see whether or not to know you have an accurate reading or not. This probe seems to have done very well. I just set it on, no matter if I set it on the top or the side, it picked it up very well, and it matched exactly what my flare said was drawing. And you saw the fluke. Well, the fluke had a little bit of inconsistencies here, and I'm using the fluke's probe, and I don't know if it's a problem with this probe, or I think it's a problem with the probe, because I've actually had better results using a different probe from a cheaper meter. Here's a probe from an X-Tech meter, and I've had better results using this probe on my Fluke. But just the fact that this was so responsive, it saw the change in current. As soon as my current dropped off and my current kicked back up again, as that PTC would draw and let off the current to maintain that temperature, it was very responsive. It saw that here as well. So very impressed with that, especially for a $100 meter. Did not expect it to be that responsive. Definitely didn't expect it to be that accurate. I'm going to call that a win. Very accurate. Very happy with the results there. I'm not going to complain about it. There's nothing to complain about there. That was very nice. And let's go ahead and do some voltage testing here on my voltage references on the DC side. I guess we should probably do the same comparison to the same two meters. I try to turn this one back on. There we go. A simple 9-volt battery, 9.87. Simple 9-volt battery, 9.857. I know, they're going in backwards here. My fault. Deal with me. I'm being dyslexic today, what can I say? That's a little easier to read. I do like how big the display is here too. That's a really nice, big, large display. Can't complain about that. And 9.8578. 9.8575 on my HP over here. 9.857. Like the outputs I'm seeing here. Now we know we have a full charged 9-volt battery, and we're going to use that on my reference here that I built, which isn't warm yet, which is a shame, because it may change as it warms up. See if it's on. Nope, there it is. I'm going to have to give this some time to warm up. It's reading 9.9997172. It will eventually warm up, but right now we know we definitely have a 9.99 without a doubt. And this should be a 5-volt range over here, 4.999. So while we give this some time to warm up, we can still check it based on those numbers. And of course 9.999 would round up to 10. Boom. Dead on. And this one should round up to 5. As it climbs, there it goes. 4.999. Okay, so it actually reads more accurate there. It didn't quite round up all the way. Very impressive. I only have one other meter that actually reads 10 volts correctly off of this, and well, beyond this guy is this cheap yellow one back here that I found in the garage when my buddy bought a house. 9.999. You know, let's change the ranges to be fair. So we got 10.000 and 5.000. And as I mentioned, this isn't warmed up. It's not going to change much. This is actually, what is this? This is the 102C reference from Texas Instrument, running an op amp, acting as a voltage divider to provide the 5-volt range. Let's turn my light back on. And you can see I get the same reading here. And I get the same, close enough, definitely with the spec reading here. And let's go ahead and move over to the fluke. And the fluke shows 10.001, well within spec. And on the 5-volt range is 5.0001, actually 5.000, bang on, with the 1 being a flickering for the least significant digit there. Still cannot complain about that. Absolutely great accuracy. Everything matches up perfect there. No complaints. Now we do have some precision capacitors here in this LRC calibration testing box. So at the frequency of about 10,000, it should read about 19.787 nanofarads. It's actually 220. Yeah, it's 210 nanofarads tied together. So it should be 20 nanofarads, but this is going by what whoever read this with the fluke PM6306 wrote it down in at the label, and they labeled it for being 19.787. Let's go ahead and check. Why not? Check the capacitance while we're at it. I'm going to set this aside so it can continue warming up. Actually, we'll leave that on. And it's on diode right now. I saw it say diode. Select it to nanofarad. Unfortunately, my HP does not do capacitance, so we won't be able to test the capacitance on the HP side. 19.89. Pretty dang good. What did I say that they said it was? 19.78? Yeah. .9, 19.8, 19.9. Believe it or not, when it comes to capacitance, the BM235 Brymen here from the EEVBlog brand, it has a higher resolution display for reading capacitance by one more digit. But still, looks good. Bang on. Good job. Good accuracy. We're done with the flare. I forgot to turn this off. There we go. So resistance, good. Voltage, good. Capacitance measurement, good. DC, good. AC, good. Frequency, hertz, good. Wow, is there anything else I can go through? There is. I forgot I had this little transistor tester here. So let me see, Brymen at 10 hertz, 9.99. And mine comes up on the HP at 10 hertz. And my fluke comes up. It was there a second ago at 10 hertz. I saw it there. What happened? Where'd it go? Let's go with the same contact pad. 10 hertz. There we go. So we're all good there. Move on to the next one. 50 hertz. 49.99. Nicely done. We'll just compare it to the fluke. .50 hertz there. 50 hertz there. 100,000 hertz. Fluke says 100,000. Brymen says 9.99. Within spec. 250 is 249.9. 250. So I'll really .002 on the HP. Impressive for such a small meter. 439.9956. I know that's very odd. 439.9. 439.99. And the only way we're going to see if we're anywhere close to 99. 439.999 should be 995. That's as close as I'm going to get it though. 439.991. But yeah, still impressive. It seems to be picking up just fine. This Brymen's holding in with the big guys here, with the more expensive guys, without a problem. 441, 443. That's 100,000 or 1,000 hertz. 2.5 kilohertz. 5,000 kilohertz. 10,000 kilohertz. Fluke comes up. 10,000 kilohertz. 25. Whoops, I think I may have reached out of its range. 25 kilohertz. Yep, we might be out of range now. I think we are. So back over to the Fluke. Make sure we're actually reading correctly. 25 kilohertz. Over to the HP. Make sure it's still putting out. 25.00020 kilohertz. Okay. So it went up to 10,000 kilohertz without an issue, but it did have its max. We're going to break out this guy. I need to test this anyway. Four millivolts picks up no problem. Let's go to 3. 3 millivolts, it picks up no problem. Okay, yeah, that's impressive. I like that. That is very, very impressive. Let's go ahead and just crank it up. 7.13. 7.13. Bring this guy up again, and let's go to 1.823. There it is. 1.823, 1.823. Just absolutely amazing accuracy off of this. This is really becoming impressive. As I said, I haven't tested this. This is brand new. This is the first time I get to play with this one too. So I get to play with both of these, and surprisingly, almost the same color. Almost. Dave's still got a nicer blue, if you ask me. That's my opinion, though. Yeah, that does surprise me. It really does. Can't believe. Oh, my down button. I cannot go down. No way. I can only hold my millivolts to go down. But I can't go down in a big range. Oh no. Go back down. Let's see where it starts again. Start over. Under 4. Fluke is showing 5 millivolts, 0.5. There we go. That's actually pretty good. That's actually very good too. I like that. I'm not going to turn this backlight on again because I'm tired of that hum. So I'm going to leave it there. So this is what we have. Let's work our scale up. 3. Now the Brymen is kind of showing the same thing the Fluke's showing, which is basically a decimal too high on that. Wait for Brymen to catch up. There it is. Okay. Not bad. The Brymen is starting to impress me. Alright, well, let's go ahead and change things around here. We actually are able to produce micro amperage out too. see if we're showing the same thing here. So we got about 5 flickering over here and about 5 flickering over here. I'm only on 3 microamps at this point. So it is consistent. It is obviously a problem with the process calibrator. 5 gives me 7. I seem to be confirming this on both meters here. 4 gives me 5. At this point it's about a microamp high, and I mean, if it was just the Brymen showing it, then I would say it was within spec. But I'm seeing it on both sides here, and it doesn't matter who gets the current first. I could reverse it. I've already done this test, and it comes up the same way. So let's go to 6, and I'm hitting closer to 8, 7, and I start to level out at about 7. So at about 7 microamps, it actually starts to push what it should be pushing out the calibrator. 8 gives me 9, and that's technically 1 milliamp, which I'm showing 11 microamps and about 10 microamps. But let's go ahead and switch over to the milliamp range and see what we get. Do the same thing over here. Not quite picking it up yet. Flickering. It's there, but it's not quite there. Of course, this is a 60,000 resolution. Or no, this is a 50,000 resolution. Sorry. This is a 6,000 resolution. So I'm not going to see that next insignificant digit that my fluke is showing. If I take this up to 11, shows 014, 12. In fact, at this point, we should probably still be in the microamp range, honestly. So very consistent results here. 13, 13, 12. 14, pushing 15. But as you can see, as I climb the scale here, it's obvious this isn't a Brymen issue. Let's just go up to 2. 21. Seems to be the average. So I'm going to go back down to 1. I just want to see how low the Brymen will actually detect. Now you see, now my fluke's actually showing the same thing, the 0.93. And again, 0.9394. 0.9394. At about 4 it shows up. At about 3 it shows up as 4. As far as that Brymen goes, it's matching up with the fluke, it's matching up with the HP. Very happy with the accuracy of this. I'm really sad I couldn't test the microamp like at 1 microamp or 2 microamp or even 3 microamp properly, but once we have 4 microamp, it's obvious. It does pick up, it reads pretty good. This is the guy that's off and putting out a little bit too much on the low end, and it's confirmed by looking at it on the fluke as well as the HP last night. So the misreadings you're seeing here to here is actually based on this thing. The only thing we really haven't checked here yet that we should check is to give it some true amperage. Let's give it some real amperage, not this microvolt amp or milliamp stuff. Let's give it some real power. So let's go ahead and give it 5 amps. 4.987. I would venture to actually believe this is more accurate than my power supply reading, so don't believe the power supply reading. 10 amps. Boom! Bang on. Beautiful. Love it. So there's our 10 amp. Came up 10 amps perfect. Cannot fault that. Looks good. So I've given it everything I have. Every possible little thing that I have on my bench, from microamps to millivolts to milliamps to amperage to constant current to voltage references, temperature readings compared to a flare. I've measured it up against a calibrated HP 34401A and a Fluke 289, which is under 3 months old, so it should still be in calibration as well. And everything I've thrown at this has just been impressive, I have to say. Again, the only little thing I hear that is a minor nuisance is that little hum with that backlight. I don't know why. In a quiet environment, that's going to bug me. I don't know why, it's just going to bug me. But typically, shouldn't be a problem. And if my power supply is on, if my oscilloscope's on, I'll probably never hear it, honestly. But, you know, it's going to bug me a little bit. I know it is. Capacitance, we gave it some high reference type capacitors there, and it checked off just about banging on that. We gave it frequencies all the way up to 10 kilohertz, I think it was, which was within the spec, and it kept up, no problem. I don't know what else to say about this, what else I could do to it, what else I could give it. I mean, it took everything I threw at it. It did an amazing job. I really like these whole banana connectors and screw-on gold banana connector design here. These are going to be definitely used probes. And of course, these take up to 10 amps. These are 1 kilovolt rated, Cat 4 10 amp probes, and that's why I didn't put anything more than 10 amps through it when I was checking current off my power supply. I didn't want to go up to a 20 amp up to 30 seconds because I know these probes aren't rated for it, even though this can take 20 amps up to 30 seconds at a time off of its shunt. I didn't want to go there because I don't have a set of probes readily available to plug in that will actually handle 20 amps at this time. I'm going to have to make a 20 amp wire if I want to test that in the future. But for right now, 10 amp was dead on, 5 amp was dead on, micro amp was dead on, everything was dead on. Really an impressive meter, an impressive little Brymen meter for the BM235 true RMS. The little high pitch hum in the backlight, okay, that might annoy me eventually, but still. Nice big display, easy, good, readable, without turning on the backlight. Can't fault it too bad. And the switch feels really good, really responsive, really easy to control. It's got deep settings. You definitely know your fingers are in there, and it doesn't turn easy, but it doesn't turn too hard either. Real good responsive feedback on it, saying, hey, I'm clicked into the right position. You know exactly where you are. And of course, the probe detectors telling you that you're plugged into the wrong jack is really good. UL certified, and I believe also CE certified also, and I'm not talking about trying to export, you know what I mean. The stand is held up well. Great little meter. This was not given to me. Most of the items I review on my channel are done by me and purchased by me. Just like this meter was purchased by me, this Fluke was purchased by me, all this equipment, pretty much everything here you see today was purchased by me. Now, the meter that I used to check the microvolt and the microamp and the milliamp range, that was provided to me for testing. So we'll give a thanks for that meter, but I'm not done the review on that, and further testing along with that as well. But as far as this meter, really nice, great little buy. Absolutely love it. Can't go wrong. And highly recommend it. And I love the fact that it even has like a little screw spot here. So if you have a screw in the wall, you just hang it. That's awesome. I love it. So as I was cleaning up, I recognized one little attention to detail. And sometimes it's all about the little things that make a difference. And I figured I should show you this detail. Now, the Fluke has these little probe holders in the back too. But my 289 is so long, you can wrap the cables up at the bottom, still put the probes in the holder up top here, and the probes, the bottom of the probes won't come near the cables. But we're talking a very long meter, being a 289. Now, Brymen making this such a small meter to fit in your hand, kind of comparable to this X-Tech rebranded Southwire here. A little bit larger, but also a nicer display, and also Cat 4, and also a ton of other features that this one doesn't have. But what this does have, and these are the original probes that came with this meter, this has the same kind of probe holder in the back. Now watch this. As I take the cables and I wrap these cables around, and they slowly come up to the top here. Unwind them real quick. There we go. And then I take my probes. We'll bring the probes up top here, and we'll snap them into place. See what happens there? My probes don't sit flush. They don't sit against the meter. And when you set it down, this is what happens usually. Well, if you set it down too hard, sometimes they pop right back out again. You have to snap them back in. So now your meter's actually sitting crooked and rocking on your bench. It's just, I don't know. It won't, yeah, you know. Little attention to details. Look at this. Brymen actually thought of that. They made this little bit of curvature right there. Just this little bit of arch. Not much at all. And you think this contour was, you know, with thought in mind for you to hold it in your hand? I actually think the contour had a multi-purpose. I think they said, hey, when I wrap my wires around and I go to store this meter, the first thing I notice is my probes are popping out. Oh, okay. So all we have to do is bring the probes down a little bit, or not the probes, add a little contour to the case. So now when you add your probes, that little contour adds space for the wire of the probes and that silicone wire there, and it's nice and flat. So when you set this down, it's flat. Look at that. It doesn't rock. It doesn't move. It doesn't pop out. I can't push down and cause this probe to pop out. It's perfect. It's not this. It's not sloppy. I mean, someone over here said, well, let's just put these things on the back so you can put your probes in there. But they didn't think of anything past that. It's the first thought and then no afterthought. No test, no use. You know, what's the customer actually going to think of this model? Is it going to work for them? Are they actually going to use this? No, I never use this. I never use this because of that reason, actually. And as I was cleaning up, I thought to myself, you know, the Brymen has these little holders in the back too. Maybe I should check that and test that real quick. Wow. That's nice. I like it. It fits. It's flat. And I thought that contour, that little cut there, I thought that was for my hand. Apparently not. It was for the probes. Or was it for both? But I respect that. It's the little attention to detail. I respect that in everything I buy. Any manufacturer and any engineer that takes their time to do that little attention to detail, they got my respect. I like that stuff. So, I just want to show you that real quick. Alright, thanks for watching. If you enjoyed this video, please give me a thumbs up, and please subscribe for more future videos coming out here in the future on more meters that I'll be doing reviews on. Again, thanks for watching. And yeah, hope you enjoyed the video. Give it a thumbs up and keep on tinkering. And Dave, I'm sure when you get more of these in, people will be snatching them up. I know I got about 5 people in line already. They're waiting for your stock to come back.